I believe I'm recording right now. Share your screen. Okay. Like you have seen, like probably if you were not in this class right now, you could have missed the first portion, the most important portion. That's why I try to be in class. For example, yesterday I missed recording the class. I thought I was recording, but it wasn't recording. So try to be in the class. Right now it's recording. Anyway, so you know right now what is the yield strength. Why we are looking, why our objective is to determine the yield strength or yield stress. Why we are looking at the strain. Why we are trying to find out what is the modulus of elasticity, right? What is the modulus of elasticity? 29,000 KSI, right? What did we get? This is for aluminum. 21. So something is wrong, right? Because why? This line is not perfectly linear, but in theory, it is perfectly linear. When it's linear, slope of this line should be 29,000 KSI. So what other questions? I believe I made it clear at this stage because you have all the resources that you need, but I don't want you to copy and paste the same data from this or from any other handout. Just use this tensile test data right here. If you look under the tensile experiment, click under the tensile data, it says measure the data. Measured data for the tensile test can be found in the Excel spreadsheet. Measured data for the tensile test can be found in the Excel spreadsheet. Refer to the sample tensile test report and the lecture video to prepare your report. Report due is 9/15/2020. So I assume that people who turned their report already, they did not even look at the due date. They did not even look at what the handouts were saying. They did not even watch my video. So if you're trying to pass this class without looking into what you have, what I prepared, I don't know when is the withdrawal date, but you can drop out the class. I'm this serious. So let's look at it. Let's look at what you have. Okay. I changed things on this spreadsheet today. The date was today. One second. I modified today 11:39 because I found out that I upload the solution for steel. So it included my solution. I worked out the stresses and strain and Young's modulus. I even worked it out this. See, I even forgot to erase this. So some of the students, they copy and paste what I have over here. And they didn't even take a look at what the aluminum data was. Like over here, if you look at the tabs, sorry for the typo, you have aluminum here, steel and aluminum. And objective makes it clear. Objective of this report, we are comparing two specimens, steel and aluminum. So make sure this week you come here, copy, and then go open the other spreadsheet. And then this go to aluminum. or let's paste it here. Assume this is aluminum. And then start putting the equations.
I have a question.
Go ahead.
On your data sheet, is the elastic or plastic regions accurate? Like, did you move them?
Yes, you can move them. Like I said, it is changing. That's what I was trying.
I was just asking, like, are they accurate to the
No, they are
data
not
that you
accurate.
have?
They are not accurate. It was accurate for my data for previous years. So what I did, I just erased the data points, but I didn't adjust it because I don't know what the elastic region, where the elastic region ends, where the plastic region starts, you know? So if I come here and if I click merge and center, and if my elastic region ends right at this location, that's highlighted here, I can come here and I can merge it again. Now this is my elastic region, right? So I come here, unmerge it, sorry. And merge it. So now, take outside borders. And this is no fill. Perfect. And if you are not sure about the color, there you go. So this is adjusted version. So I'm assuming that my elastic region ends right here, right now. I'm assuming, let's say this is 36. Let's say if it's 36 KSI, it's 36 KSI at this point. And elastic region ends, and the material gets into plastic stage. Make sense? So this is how you adjust it. Did you understand? Who was asking?
Thank you.
No problem. No problem. Okay. So I can close this. And the sample report. We are done with this. And PowerPoint. You can take a look at the PowerPoint, but it's the other files are much more important than the PowerPoint. Okay, torsion experiment. So our syllabus was saying different, but I want to start torsion for today, and then I changed my mind again last minute this morning, but after I look at the syllabus, because I need my assistant to help me to run the experiment. And I was supposed to have in class, I was gonna have 10 students every week, but I received emails and phone calls from a couple students saying that they were already contracted to COVID-19. And my wife is 8 months pregnant, and I don't want to have any problem with the COVID-19. I'm just taking precautions. So if you put yourself in my shoes, what would you do? Even if you believe the COVID-19 is true or not, I have never got sick during COVID-19, but just in case. You're more than welcome to come to see me in my office. Like there were a couple of students came today, and I spent my day here yesterday and today. If you come here on Tuesdays and Wednesday, if you give me a call in advance, in 1 hour in advance or 2 hours, I can come meet you face to face. If you have questions, I'll be here. But please excuse me when it comes to face-to-face class, and it's not mandatory. There are a lot of professors that I know, they are not having face-to-face class. Some of them just because they're age, some of them just because they are just being precautious against COVID-19.
I just had COVID-19 and it's very crucial. It's bad.
I understand.
Yeah.
How do you feel now?
I feel 100% now, but 9-10 days I was very sick. It's horrible.
I understand. Sorry to hear that. So imagine if you were in the same class with Ronald, what would you do? So you're gonna blame on him, but he doesn't have anything to do with it. So nobody can blame anybody. You can, I mean, you might blame on the University of New Orleans, but we cannot make everybody happy in this, if I have 50 students. Because some of them, they want to have face-to-face class, some of them, they prefer online class, some of them are sick. I mean, I might get sick. As a matter of fact, I wasn't sick yet last week, but my wife went to emergency. It's because she's pregnant. So I canceled the class, but I have my files on Moodle for you to watch it and for you to follow the class. So I believe right now, nobody has excuse on completing their report or not having enough resources to complete their coursework. Okay, so I'm looking at this syllabus right now. So introduction, we covered the introduction. Even though I forgot to record the video, you should have the syllabus, you should have the book that I posted, and you should have seen, you should have heard from your friend what is the coursework about, or if you have not, give me a call. And the tensile test. I did the tensile test, and I still trying to explain the tensile test for those of you who has not follow up with the class. But today is the last day for the tensile test. I'm not gonna go back and explain tensile test again and again, because probably half of the class or more than half of the class, they already mastered the tensile test. And week 3, which was September the 2nd, but I canceled that class and I told you guys to go to YouTube channel or go to Moodle and look at the files. So today we're gonna prepare this concrete cylinders from pre-mixed concrete, Quikrete concrete bag. And you can see the bag right here, if you can see it, right there. I have 2 bags, one for today, one for next week, Tuesday. Anyway, is there any complaint about this schedule? Good. Good. Okay.
I have a quick question.
Who am I talking to?
Celine.
Nice to meet you, Celine. Can I see your face? So I know who am I talking to? Okay, Celine. I saw you in the morning.
I was just curious. I was looking at the schedule earlier, and like last week you had an emergency, so it pushed us back a week. Is that going to change our later schedule, like our final exam schedule?
No, we usually finish semester early, 2 weeks earlier than other classes. So I have hurricane holdouts. If you look at the schedule, let me pull up the syllabus again. I close it, but let me look it up again. Okay, I have week 14, week 15, and another week. So we have 3 weeks. I usually give the final exam before other courses. So let's say you take in thermodynamics, or let's say mechanics of materials lecture, they are having the final exam in the final exam week. But I prefer to have the final exam before the final exam week, so that you can have time for you to study for other classes. So I finish up, and also I can study it also, because I'm taking 3 courses and dissertation hours. So it's helping me, it's win-win scenario. So you win and I win. So if
Yeah, I'm just curious. I was just wondering, because I'm going out of town, and I just want to make sure like I'm on top of my schedule before I go out of town for the final exam.
Well, even if you're going out of town, you're going to be online, right? You can be online on your phone, you can be online on your laptop, and you can take the exam online.
Yeah,
So,
I was just curious if it was just pushing it back after or before, just to be on the safe side.
okay, we are on the safe side. Trust me, you're gonna have your final exam on time or a bit earlier than other classes.
Okay, thank you.
Okay? No problem. You're welcome. Okay, with that being said, I'm gonna skip the torsion part. I'm gonna get into torsion in 2 weeks, because if I prepare this concrete today, if I put it in the cylinders, I have to test my first cylinder in 7 days to compare with the 28-day results. I want to see what are the changes in the concrete cylinders between 7 and 28 days samples. Is it going to gain more strength? Is it going to lose the strength? Or what are the changes? Because in this case, we are not comparing apples and oranges like aluminum and steel. We are looking at the same material, only thing is changing, curing time. That's it. How time affects the concrete curing condition or concrete strength. That's what we're gonna look at. So, I'm sharing the screen. Okay, let's look at this I'm gonna get into handouts, but let's go to PowerPoint. PowerPoint. Okay. Again, this is my number. For those of you who have not received or who have not saved my number, take my number. Class schedule, today's topics. There's only one topic. It's Introduction to Concrete Compression Experiment. Like I said, this concrete compression test consists of 3 phases. First phase is the concrete. We're going to prepare the concrete batches from the pre-mixed concrete batch. And the second phase, we will test our first cylinder. I'm going to show you. Okay, this is one of them. 6 by 2, 6 by 12. 12. I believe this is 12. 12. Yes, 6 inch in diameter and 12 inch height. This is from last year, and I can even test this one to see what happened. Because if you look at the concrete strength that was advertised on the bag, it says 4,000 psi after 28 days. But if you cure more, it gains more strength. Every day it's gaining more strength. Okay, I have 2 cylinders right there. I'm gonna perform the slump test, and then we should be out of here in 30 minutes, hopefully. Okay. Introduction. What do you see here? Let me see, 1 second. Okay. So who can tell me what is concrete and what is it made of? I'm trying to have conversation with the students. I can go to Christian. That's you. I select you. You tell me, what do you understand when you, what can you tell me about concrete? Because you see concrete every day in your life. You walk out of your door, you look at the patio, you look at the driveway, you look at the concrete pavement on the street. What do you?
I'm not sure. I don't know much about concrete, but I do know that it's like a mixture of dry materials that when mixed with water, they combine and harden to be a firm substance.
That's perfect. What about Piero?
I know it takes a long time to cure. They use it for lifting houses. Pretty cheap in comparison, right?
Pretty cheap.
Yeah, that's about it.
Other stuff. What about Mamie? Mamie Shaw?
Sorry, I had to find the space bar.
Okay.
Did you ask, are we still on what is concrete or like what do we use it for?
Yes, we are still looking at the concrete, and I'm trying to understand what this concrete is made of and what is the purpose of this concrete, how we use it, why we use it, and when do we use it? Simple questions and simple answers.
We use it because it's a very durable material and it's easily formable the way you make it.
Thank you, thank you. Okay, and now let's look at my answer. What is this concrete and what is it made of? So concrete is one of the most versatile and widely used construction material on the earth. It is strong, durable, low maintenance, fire resistant, simple to use, and can be made to fit any size or shape. For example, look at this huge bridge pier. Or you can look at these skyscrapers. It is cheap compared to other materials. Concrete is a complete bargain. For example, this concrete bag that I have, guess how much I paid for 80 pounds of concrete mix?
Like 20 bucks.
Go down. Way down. How much?
4.
Maybe $5.
Okay, $5. Who am I speaking to? $5?
Mark.
Mark? Okay, Mark, are you working in the construction industry?
No, but I've done like projects and stuff like that at home in the past.
Right. Like I said from the beginning of the class, money is the matter. We're trying to save some money, and we're trying to find economical construction materials to lower the cost down, right? So concrete is cheap, and I paid $4 and some change, and I'm gonna look at it how much it is online. This is the benefit of having online class, so I can pull up on. Okay. So Quikrete. So you know what material I'm using, even though you have the handouts on Moodle. I assume that it will take a couple of weeks for you to look at the files. So let's look at this Quikrete concrete at Home Depot. Lowe's, $5.20. Oh, I got it cheaper because I got through UNO, so it was tax-free. So this is the material that we are using, not the mortar mix. I'm sorry. Quikrete, mortar, concrete mix. That's it. So it goes, price goes higher if you go to different stores, but try to stick with the big stores so you can get cheaper deal. So it was $64 for me. And if you look at the description, it tells you Quikrete concrete is mixed. Quikrete concrete mix is a pre-blended mixture of cement and aggregates for general structural use, requiring only addition of water. So what I need sand, which is also known as fine aggregates. I need gravels, aka coarse aggregate. I need cement, and in order to bond this, I need to add water. So cement and water acts like a glue, right? And if I look at it, it says Quikrete is 80 pounds, high strength, 4,000 PSI concrete. So if I know it's 4,000 PSI, why I'm testing again? Like I did on steel sample. I know it's 50 KSI, you hear, 50 KSI. Why I'm testing it again? What is the purpose?
You mentioned you wanted to test different cure times.
I want to see if they are actually representing the accurate value or are advertising right or wrong. That's what I want to see.
Couldn't even just like a slight change in the mixture make it more or less durable?
Who's this?
It's Bradley.
Bradley, you're right. So they are saying that this 80-pound high-strength concrete has 4,000 PSI strength. If you follow their directions, and I'm gonna pull up the directions. I don't want to stop going on this PowerPoint, but you will see in the other slides. If you change the cement-water ratio, if you add more water, what's going to happen? The strength will reduce, right? If you add more water, you're going to lose some strength. It's like you're making a soup or you're making a pasta, but you add more water. Okay, you're increasing the volume, but reducing the taste. Same way. You increase the volume, you increase the workability in the concrete, because if you put more water, what's going to happen is it's going to act like fluid, right? So it has pros and cons. So I want to see what will happen with the curing time, what will happen with the temperature, because even temperature it has effects on the concrete strength. So we will see these.
I have a question.
Yes, go ahead.
Why do we continuously spray it with water afterwards and like cover it?
Who is talking?
It's Bradley again.
Bradley? Okay, Bradley. If you wait 2 minutes, I'm going to explain on my slides, but just give you 5 minutes. I'm almost there. Let's continue. Okay. Let's continue with the PowerPoint because I have the answer. This is the perfect question I was going to answer regardless, because I know you guys were going to ask some of you. All right. Where I left off was, yes. So I explained why it's cheap, why it's a huge bargain, and you can see, it's easy to see why it's cheap. If we look at the materials, if you look at the elements, if you look at what it is made of. Simple. Concrete has 4 primary ingredients: water, sand, also called fine aggregate, gravel, aka a coarse aggregate. I'm sorry. The sand is fine aggregate and the gravel is coarse aggregate. And you have cement. The most common type of cement used in the concrete is known as Portland cement. So each ingredient in the concrete has a specific role to play, and cement role is to turn the concrete from liquid to solid. Portland cement cures not through drying or evaporation of the water, but through a chemical reaction called hydration. The water actually becomes a part of cured concrete. This is why you shouldn't let concrete dry out while it's curing. Bradley?
Yeah, I hear.
Okay, if you correctly understood what I said, this is the answer that you were expecting. I'm going to read one more time from my script. Portland cement cures not through drying or evaporation of the water, but through chemical reaction called hydration. So hydration, during this chemical reaction, this chemical reaction is releasing heat, and we're trying to keep the temperature lower to avoid the temperature increases because it causes additional problems. I'm not going to get into that in this lecture because if you take concrete class, you will understand why it's important. Because it takes, there is a course on concrete one semester you have to take if you're studying civil engineering. So my job is to go through the essential informations. But you should know why we are watering the concrete during the curing time, because you need more water. So this is why the process is, okay, this is why you shouldn't let the concrete dry out while it's curing. Lack of water can prematurely stop the hydration process, preventing the concrete from reaching its full strength. So if you don't water it, what's going to happen? Bradley?
It's going to crack.
It's going to crack, and it's not going to reach its full strength because you don't have enough water, right? That's why in summer times, you have to water it. Summer times, you have to add more water and spray water to prevent cracking or shrinkage, etc., etc. In fact, as long as you avoid washing out the cement, concrete made with Portland cement can be placed and cured completely underwater. It will set and harden just as well and maybe even better as if it were placed in the dry, right? So if you have more water, it's even better. As long as you don't wash out the cement, because you need two important elements, constituents, cement and water, because they act as a glue. Other aggregates such as sands and rock, they are bound together with the help of cement and water. I believe I answered your question, Bradley.
You did, thank you.
You are welcome.
I'm assuming it's a common misconception that concrete and cement are the same thing, but one is of the other.
Okay, the misconception, you are assuming the concrete and cement is the same, right?
Not necessarily me, but I'm saying other people do.
Right. That's true. That's right. If you're not in the construction field, you assume that concrete and the cement is the same. Right, but actually cement gets into chemical reaction with water and then it creates, it turns to concrete. It hardens. But cement is powder. Okay, let me continue with the introduction. I will explain each picture, why I have these pictures here, and how am I going to tie these pictures to the lecture. 1 second. So you may be wondering if water plus cement equals hard, because if you put water and the cement together, it gets harder. What is the need for the aggregate? Why do I need the aggregate? Why do I need sand? Why do I need coarse aggregate, rocks and gravels? To answer that question, let's take a closer look by cutting this sample through with a diamond blade. So you see the diamond blade at the top right corner, and I'm trying to cut this concrete cylinders so I can look at it in detail. And if you look at the left corner, you will see in details. Okay. Under a micro lens, macro, not the micro, it starts to become obvious how the individual elements contribute to the concrete. Notice how cement paste fills the gaps between fine and coarse aggregates. It serves as a binder, holding the other ingredients together. You don't build the structure from pure cement the way that you don't build the furniture exclusively out of wood glue. Instead, we use cheaper filler materials, gravel, and sand to make up the bulk of concrete volume. So we try, if you use cement rather than rocks and the sand, it's going to be costly, right? This saves cost, but the aggregates also improve the structural properties of the concrete by increasing the strength and reducing the amount of shrinkage as the concrete cures. Because as the concrete cures, cement gets into chemical reaction with water and shrinkage starts occurring. But on the other side, rock or sand, it doesn't go through chemical reaction. It stays as it is. And rock by itself, it is strong, or sand. As long as you bind them together, you are increasing the strength of your material that you are creating. I believe this answered your question. I don't know who was asking the question, but this might be the answer for your question. The difference between cement and the concrete, etc. So what about the water? What about the water? I explained that rock, sand, cement. What is the water? Obviously, the more water you add to your concrete, the easier it flows into forms. This can make big difference to the people who are placing it. Also known as, these people are the construction workers or concrete form workers, etc. They are skilled workers, and it's hard to find concrete workers in the United States. Where I come from, in Eastern Europe or Middle East, wherever you name it, Turkey, it's in the between Europe and Middle East. We have a lot of concrete structures, and labor is cheap when it comes to concrete structures. That's why we have a lot of concrete structures. But over here in the United States, it's more into steel and timber because it's hard to find skilled workers, expensive. Again, it's cost. It all goes to the cost. Also, adding water increases the workability, but the workability comes at a cost to the concrete strength. Like I said at the beginning, if you add more water, okay, you will increase the workability, and your concrete mixture is going to flow without having any problems into this formwork. If you look at this, the reinforced, if you look at this lower right corner, this pier, bridge pier, it will be hard to place concrete if the workability of concrete is not enough. But there are ways to increase workability without adding waters, and I'm gonna explain these methods and these additional admixtures that goes into concrete at the end of the class, because we have 2 more classes for concrete, so I'm gonna cut it short today and I will continue later on. So one way of checking the workability of concrete is called slump test, which we will perform today. This is the concrete mix that we're going to use today. If you look at the product description that I already explained on Google, it is pre-mixed, pre-blended mixture of cement aggregates for general structural uses. You can have it and you can try it at home as well. If you look at the tutorials that I have on Moodle, you can make some small structures in your backyard. Okay. Physical and chemical properties. Quikrete concrete mix exceeds the compressive strength requirements of ASTM, American Society of Testing Materials, C387, as shown in Table 1. It exceeds, but it's not less than. So they're saying that what these values are, 2,500 PSI or 4,000 PSI or 2-inch to 3-inch slump range, it's not going to be lower than what we present, as long as you follow the direction. And I'm going to get into directions, and we will follow the procedures, follow the directions, and make our own mixture. So what this table tells you, I'm gonna ask this question to luckiest person, Matt Garrett. What do you understand when you look at the table 1? What? Okay, let's say you went to let's say you want to have a patio or driveway. You want to build your own driveway, and you went to Lowe's or Home Depot, and you are looking for concrete mix, pre-mix. You don't want to get your aggregate from somewhere else. You don't want to get your cement from different company. You want to get it from one place. It's already pre-mix. All you need to add water. What do you understand from this table? I'm not going to blame you if you don't understand anything, because I don't.
You better be ready not to use your driveway for a month.
What is it?
You better be ready not to use your driveway for a month.
Yes.
The 28-day cure time for full cure.
But there are ways to increase the curing time. I mean, reduce the curing time, I'm sorry. So I can get this driveway ready in overnight, to be honest. Because if you work for DOTD, if you are let's say you have a construction project on a highway somewhere in I-10, and you're trying to get this construction done and pour your concrete overnight, so next day you can open this traffic, right? So you can add different admixtures, and you can find these admixtures based on your requirement on the handout that I provided on Moodle. So if you pick those admixtures, whatever is desired criteria, you can reduce the curing time. You can even reduce the shrinkage, or you can change the temperature that's going to take place during curing time. If you add sugar, for example, even sugar, the sugar that you use for your coffee.
On that note, like when people like pouring like in ocean structures where it's salt water, does that affect cure times or how hard it cures?
Well, definitely. If you are doing construction on a water, you have to use different admixtures to prevent the possible failures. I can't think of on top of my head because I haven't worked on the construction that was taking place on offshore, but I can find out for you. Also, during class, please do not use your phone. If you're looking at your phone, you're not going to understand what's going on. Okay, so I'm going to tell you what I understand when I look at this table. So I'm buying this product, and I want to know what are the strength values that I'm going to get. What is the strength that I'm expected to have in 7 days? So I can open this driveway in 7 days or 28 days, let's say, without adding any admixtures. So I look at it and I see that on 7 days, I have 2,500 PSI strength. So I'm shooting for 2,500. If everything goes as planned, as expected, I'm gonna get 2,500 PSI strength. If not, something is wrong. Either I added too much water or the temperature was not right during curing time, because usually you have to cure these concrete cylinders in a humidity room. So you have to keep the temperature and humidity constant to get the perfect result. But in field, it's not possible because weather is changing constantly. Because in nighttime, different temperature, daytime, different temperature. That's why you have different admixture of chemical composition into the concrete mix to avoid these mistakes. But in 28 days, I should have 4,000 PSI, and imagine 4,000 PSI is good enough for you, for your driveway. Imagine 4,000 pounds every square inch of your concrete driveway is experiencing. Right, 4,000 pounds. It can, I think it's your, if you have a truck, your truck probably 10,000 pounds or 6,000 pounds. Slump range. We didn't get into slump, but only thing I explained about slump was it tells you your concrete's workability. Slump range, and I'm expecting 2 to 3 inches. And we will see after I perform the slump test, what is the slump. If it's not falling between 2 and 3 inches, that means something is wrong. And I know already, right off the bat, the 7 days strength is not going to be 2500. If it's more than 3 inches, it means it has more water inside, and the 7 day strength will be less than 2500. But the slump, if the slump is less than 2 inches, that means I added less water, and the strength will be more if the curing condition is okay. Because what I do usually with our curing room is not working properly, I keep these cylinders right here. I don't know if I can show on this, right there in this, where the tap water is. And I keep adding water into the concrete sample when it's curing. So I keep watering and I keep the hydration going throughout the curing time. But it's not perfect. You have to have your curing room ready if you are shooting these values. But we will see if it's 2500 at the 7 days or 4000 psi at 28 days. This is our goal. See how these conditions are affecting the strength of your concrete. Right. So, and you also need to look at use of this product use. You know, if you're shooting for driveway, let's see if it is okay, or sidewalks. So this concrete is okay for foundation walls, footings, sidewalks, curbs, steps, pipe, post footings, floor slabs, patios, pools, etc. Because 4000 is good enough. But also you can have 3000 psi concrete for smaller jobs. But if you are working on this type of project, you should have minimum 5,000–6,000 psi concrete, minimum. I'm just giving the arbitrary number, but it's not going to be 4,000. Okay. I mentioned this at the beginning of the class. This was supposed to be the only handout that you were supposed to get this semester. So let's look at this handout. Title, that's going to go to your title page. You should start typing this report as soon as possible because you already have the essential information for the theory sections after this lecture. You have your objective. I'm going to repeat again. Our objective is to prepare a batch of concrete from pre-mixed bags from Quikrete, perform a slump test, and you already know what the slump test is, and prepare 2 6x12" cylinders, and I already showed you guys what those cylinders look like. This one, this is 12 inch by 6 inch, right? And again, if I know this cross section, if I know the diameter, I can calculate the cross sectional area. I need the cross sectional area to calculate the stress, like you did in the tensile test. Okay. And then this was today's experiment, but next week we're going to perform compression test in 7 days to see if we're going to get to 2500 psi. And 28 days we're going to perform another one, 7 and 28 days. If you cannot read this, go to the sample report. I'm going to go to the sample report on Moodle. So if you cannot read this handwritten section, you can go to the next slide. And then we're going to determine and draw stress and strain diagrams from the compression test results. Stress and strain, same thing. If I'm repeating stress and strain every class, that means it's important for you. And you should know. Okay, I'll look at the equations and theory sections. This theory section is so short, it has only 1, 2, 3, 4 equations, right? But I want you to explain these equations, define them, so that I understand when I read your report, I understand that, and I have a clue that you understood what these equations where to use them, when to use them, and how to use them. First equation is the same as we have seen on the tensile. Sigma is the stress, and it can be calculated by dividing the load, applied load, by the cross-sectional area. And I explain how to calculate the cross-sectional area. I show the cylinder 6x12, and the cross-section, if I cut the cylinder in half, I can see what is the diameter, and I can calculate the cross-sectional area. This way, I can calculate the intensity of the applied force. Okay, let's say I'm applying 1,000 pounds onto this cylinder. I apply 1,000 pounds, right? Entire cross section is experiencing 1,000 pounds. But I want to know, what about the every inch square? This is not 1 inch square. Calculate the area. Maybe area is calculated. Okay, if you look at the slide, area is calculated. Pi d squared. Pi r squared. I'm sorry. It is 28.3 inch square. If I apply 1,000 pounds, I have to divide that 1,000 pounds by 28.3 inch square to calculate what is the intensity of this applied force and what is the internal stress, unit stress. Okay. Okay. So let's look at the other equation. This epsilon is the strain. To calculate strain, I will ask a lucky person, Kate. I'm sorry for disturbing you, but you have to answer this question really quick. What this equation tells you, epsilon, delta L divided by L. Kate?
In this case, because we're doing 6x12.
Nobody here heard you yet. Look, can you repeat one more time?
It's the formula is delta L over L, which is 12 in this case.
Which is what?
12.
Yes, delta L, exactly. L is the gauge length. Is in this handout it is 8. But these cylinders this is old handout that was made by Norma Jean, Dr. Norma Jean.
So we have 6x12 cylinders, right?
By 12, yes. I will measure it again, but this should be 12. I measure it. Let's make sure. It is start from 1. Yes, it's 12. So you can change the handout to 12. But you don't even have to use this handout because you're going to have the exact spreadsheet. You already have the spreadsheet on Moodle. Okay, so you got the right answer. Thank you, Kate. So we're going to see the deformation per unit length. So I know what the deformation is the same way that I was explaining to Tim, I believe, on the board, right? If you look at the board, I have the applied load in one column. So if I apply 1,000 pounds right here, let me see if I can, if I'm showing the, 1 second. Okay. I don't know if it's clear to see, but when I apply 1,000 pounds, I have to look at elongation. And once I recorded the elongation, corresponding to the applied load, I have to calculate the deformation per unit length, right? So I had to divide it by the gauge length, which was 12 inch in our case, not the 8 inch. Okay, so let's go look at the other third equation. It is E concrete, E subconcrete, C-O-N-C. I'm going to find another person. Let's see. Richard Laurent. Can I see you first? Richard? I guess Richard is not here. What about Caden? Richard is not here.
Richard Richard is here. He's just still on mute.
Okay, Richard. Okay, I will. If I find him again, I'll mute him. But let's go to Wesley then. I can't find him. Wesley, are you here?
Yeah.
Okay, Wesley, can you please explain to me what is this equation? You have seen this equation in previous example, tensile test. E equals sigma divided by epsilon. Sigma stands for stress. Epsilon stands for deformation. In other words, strain. So if you divide stress by strain, what do you get? Modulus of elasticity, right? And it tells you how strong your material is and how it is resistant to deformation, right? If I know the deformation value, if I know the modulus of elasticity, first of all, I can calculate the stress. If I have one or another, if I have the E and the epsilon, I can calculate the stress. I can go to this table, this graph, and the y-axis in this graph is representing the stress, and the x-axis is representing the strain values. And if you look at this graph in details, there are values, E7, E sub 7, and E.
Could you scroll down some? You can't see the whole graph.
You can't see the whole graph? Yeah. Okay. Let's make this graph available on Moodle. I believe this graph is not available on Moodle, but let me see. Let me see if I can make it available for you. Okay. So there are two ways to calculate the modulus of elasticity of concrete. One way is to calculate from graph that you will generate using the data, using the data points from the experiment. The other way is to using this equation. This equation was given by American Concrete Institute, and it's in PSI. Whatever number you put inside, it has to be in PSI, pounds square inch. F prime C is the concrete compressive strength. F prime C. It was 4,000 PSI in our case because it was shown right here. So if I plug in 4,000 PSI into this equation at 28 days, let's see what we're gonna get. And you can compare this with the one that you found from the graph. So it tells you, let's look at the theoretical definition of modulus of elasticity. Modulus of elasticity of concrete, what it is. The modulus of elasticity of concrete is relatively constant at a low stress levels, but starts decreasing at a high stress levels as matrix cracking develops. This is not the answer that I'm looking for. I'm looking more simplified answer. Okay, right here. This is for contractors construction, so it's more easier because they are not engineers. So modulus of elasticity of concrete, E sub C, is defined as the ratio of applied stress to the corresponding strain. Not only does it demonstrate, okay, this is the perfect definition. Excuse me. Okay, same equation, stress divided by strain. F is stress in this case. Modulus of elasticity, also known as elastic modulus, the coefficient of elasticity, in other words, it is the material, of a material is a number which is defined by the ratio of applied stress to the corresponding strain within the elastic limit. So elastic limit is important, right? I explained this elastic limit in the beginning of class while I was explaining the spreadsheet. You have your elastic region, you have your plastic region. Same way you have the elastic and plastic region in concrete. So you can only calculate the modulus of elasticity. It doesn't matter if it's steel, aluminum, or it is a concrete. You can calculate in the elastic region, because you have a linear portion in the elastic region, and it's the slope. It is the ratio. It says right here, it is the ratio of the applied stress to the corresponding strain within the elastic limit. First, you have to define your elastic limit, where it is, where it ends. And then you're gonna zoom into that limit, and then you can look at the ratio of stress to the corresponding strain, which is the slope, in other words, because it is linear portion. Physically, it indicates a material's resistance to being deformed. So it tells you how strong this material is to deformation. I'm going to repeat one more time. Physically, it indicates a material's resistance to being deformed when a stress is applied to it. Modulus of elasticity also indicates the stiffness of a material. Value of elastic modulus is higher for stiffer materials. And this is the equation. F is applied stress on a body, and S is the strain to correspond to the applied stress. This is the exact test we're going to perform. There are a lot of cables. Those cables are measuring the deformation. And if you look at this UHTM again, right here, Tenius Olsen, the top portion, actually, I can go closer. Let me go closer. Okay. So, this upper portion, are you guys able to see this video?
Yes, sir.
Okay. So, if you look at the upper portion right here, what do you see?
Crosshead.
Yeah, crosshead. Yes, you have upper crosshead and middle crosshead. And this is the tensile specimen that I put it in. I was testing yesterday. And the bottom portion is working for compression. So I'm going to put it over here. Let's see if you can still see it. Okay. And this is one of our samples. It goes right here. But I have to change the top. This one. It's going to take time to take this one off, but I'm not going to take it off fully. But I have to take the parts that was used for the tensile testing, and I have to put this part into the in place to test my concrete, because if you see, it's a smooth surface. So I'm going to be able to apply this load uniformly, right, on the concrete. On top of that, I have these caps. These caps are going on top of the cylinder. So who can answer right now why I have these caps on top of the concrete? What is the reason that I have to put cap?
To ensure that the force is applied evenly, and so you protect those plates, because the plates are a lot more expensive than the caps. If the,
right, it's always for the cost. I know the economical reasons, but in this case, it is used to ensure the uniform load. Like the load that we are applying is uniformly distributed if you have the caps. We usually put sulfur cap. When you put sulfur cap, it's a chemical mixture. It gives you smooth surface. Even though this one is smooth surface. Okay, looking close. Even though this is smooth surface, it fails right here. Why is the reason this material has failed in this corner? 10-point bonus.
The load was not distributed evenly?
Hmm?
Was the load not distributed evenly?
Correct, but you cannot get a 10-point for this. One more step. Okay, that was the stress development. The answer is correct. Tim.
Oh wait, was it that little thing that hit it? Oh, my bad.
No, what happened was the stress was not uniformly distributed, and there was a stress accumulation at this stage, right? So all the stress went to this corner, and it fell from the corner. Even though you have the entire place right here, nothing happened. So to avoid this, we use the cap. Sulfur cap, on top of the sulfur cap, we use the plates. Okay? So what happens, I run this machine. Okay, this bottom, actually it's top. Bottom stays fixed during the testing. The top middle portion, it starts applying force. It's pushing on the concrete. It's pushing on the concrete. Eventually, it fails. So we test our concrete and the bottom portion. We test our steel and aluminum right here at the top. And then you have the torsion. Or we're going to see the torsion. Probably some of you guys have been here before, but in torsion, these are the samples that I tested in previous years. This is after testing. This is before testing. And I have the same problem here. I can ask the same question, why this material failed in this form. If you look at closely, it failed at the end. Instead of failing in the middle. The problem was the stress was developed at the end. It was applying additional torque at the end because we didn't place this material specimen correctly. If you don't place it correctly, all the stress will develop at the end, and it will fail at the end. It's called premature failure. Okay, good. Are you okay, Andrea? Thank you. Okay, let's go back. It's 5. We have 30 more minutes. 5 p.m. One second. Share screen. Share this. Share. Okay. Give me 1 second. Perfect. Okay. Now we can continue. I have one more slide, but let me finish this. All right. So in this handout, every semester we measure some values. The first measurement that we take was the length and the diameter of the sample, 6 by 12. And the second measurement will be the slump. I want to see what the slump is. I want to see if we are in the range 2 to 3 inches. If it's not, I intuitively know that I'm not going to be able to reach 2500 psi, or I will go beyond 2500 psi if it is less than 2 inches. It will tell me at the beginning. So usually, let me pull up the one more file on Moodle. There is the file called concrete receipt right here. This is me when I was working in the construction. I will download this, rotate clockwise, counterclockwise. Okay. So you're an engineer or inspector. Let's say you are responsible for this site. This job site was in mid-city, somewhere in mid-city. And you see over here where it's coming from, customer ID, and water added, 10 gallons of water was added into this truck. And you see who's receiving the concrete, BF Construction, and the address. and the quantity is 10 cubic, is usually in cubic yard. And quantity, you got the quantity, there is a slump right here. You see the slump, 4 inch. Are you guys able to see the slump?
Yes,
Okay,
sir.
4 inch. So I'm on the construction side. I got the concrete truck, and this guy tells me it's 4 inch. Why would I believe him? Tell me one reason why would I believe someone that I don't even know? Why would I risk my job by just having this piece of paper? Or tell me why it will be risky to accept this concrete.
Because if something goes wrong, you could end up with like a collapsed building or a failed bridge, and you could end up accidentally killing people if the concrete fails.
Exactly. So once I sign this paper, because it has 3 copies, if I'm not mistaken. If you can see, it has the pink and yellow copy. I get one of them, and the truck driver gets one of them, and there is one more inspector, third party. Imagine why, like think of it this way. Why would they have another inspector? They already have the project manager. They are trying to, like, if something goes wrong, they can blame on somebody. That's why they cannot solve the problem in Hard Rock Hotel still. It's been a year. So in order to prevent these problems, it doesn't matter they call you a bad guy that don't accept this concrete, but you're doing your job. You look at the slump, and then you're gonna take your slump cone and you're gonna test it. See if it's 4 inch. If it's not 4 inch, you already know it's not gonna be, let's say, how many pounds square inch? Let's say 4,000. It's not 4,000 PSI. On top of that, this is not enough. You test it. If the slump is okay, you proceed and you start pouring your concrete. But in the meantime, from that first batch, you take sample into cylinders. I have my cylinders, one of them, 3, right? It's on job site. I take my sample, 2 samples, and I take it to the lab. Not me, but the inspection company. So I'm waiting for the results. I get my results. They can tell me what the desired strength, what will be the strength of this material, concrete, in 28 days. But I don't have to wait 28 days. If I know in 7 days, I can predict, I can forecast what will be the strength in 28 days. So if it's less than advertised, I believe it was 3,500. Anybody sees the compressive strength on this
This
report?
says 3,000.
Okay, plus M 3,000 PSI, right? So they say they advertise this 3,000 PSI concrete, and I tested and my test result comes back in 7 business days, let's say. And it's not 3,000 PSI, it's 2,500 PSI. What's gonna happen? 2,500 PSI, it's less than 3,000 PSI. You assume that it's gonna rip it up, exactly. You're gonna do demolition, take it out the concrete, bad one, and then pour another one. Who's responsible? Not you, this company, Lafarge, or any other company, whatever. I'm not affiliated with this company, but it can be any other company. So your job is to check these. And you should know, you should understand by now why this is important, why I'm trying to explain the slump over and over, or the concrete compressive strength, because this is gonna see in the field. Imagine you skip this part, you didn't understand the slump test, you didn't understand the concrete compression test, and you go and take the job. Somehow you convince your company, your HR department that to interview you, but you're on job site and you don't know what to do. And let's say in order to get away with it, you just sign the paperwork. Now you have responsibility. Who are you gonna blame? Me? Because I didn't teach you? No, it's you. Okay. So, also one more thing is important. Time. Time is 12:18, and there should be a time due at job. 1 p.m. If it is more than 90 minutes, 1 hour and 30 minutes, don't accept it. because it's not good anymore. Because concrete stops curing after 90 minutes. If it's already curing in the truck, it's not good. So you should return it and you get a new batch, and it's your right. You can receive a new batch of concrete if it's more than 90 days. They will try to convince you, but you're gonna say no. No means no.
Wouldn't that depend on the type of concrete as well?
Yes, it depends on the concrete too. So first of all, you're gonna know what you're getting into. You know, you're gonna know what you are buying. If you don't know what type of concrete you're expecting to have on job site, then you don't know what to ask it or what to expect, you know, what to check. So before you order concrete, I assume that your project manager, or if you're a project manager, you should know what to expect from this concrete. And so you can check, or you can let your project inspector or project engineer to know what to check. So every time what I was checking was time, I was checking the concrete compressive strength, and I was checking the slump and the quantity, pretty much these. So I checked 3-4 different things.
Can I ask a question?
Don't ask hard question, go ahead.
Okay, for the slump, this is the first time that I've ever even considered looking at concrete. So what exactly is the slump? Like, is it you said that it's how much it moves, how... This is Andrea. My picture's up there.
Andrea, I'm trying to see you, Andrea. Okay, Andrea, okay, I see you. So we're gonna get to slump right now, and I'm gonna show you slump because I assume that you guys are not familiar. There's a handout here called slump test. Slump test. Let's look at this handout. And I have the ACI, American Concrete Institute slump test, ASTM C143. I have the video, okay?
Second left.
I will perform every single step that this guy is doing. This is slump cone. Are you guys able to see the screen?
Yes, sir.
Yes.
Okay. I think video is better than the handout right now. And please watch it carefully because I'm gonna select random person in this class and I'm gonna ask him to direct me while I'm doing the same thing right here. So if you don't watch it, and if I ask you, it's a big no-no. Okay.
Is moist. Do is make sure that your slump cone is moist both inside and out. Want to perform this test on a flat, smooth, rigid surface, free of any vibration.
Okay, before we start, I'm gonna ask you, Andrea, why free of vibration?
If there's vibration, it can change the way that it settles.
Exactly, perfect. Why this guy was putting water inside and outside of the cone? Trying to smooth the surface.
So it doesn't stick to the cone?
Perfect, 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 see?
It needs to be a non-absorbent surface.
Non-absorbent surface, so there's already water.
It can be held in place. You can stand on the ears or you can use the slump place and lock them into place. We'll fill the cone, 3 equal lifts by volume.
He says fill the cone, 3 equal layers. This is the most accurate process, or most, how can I say? I mean, since this was released by ACI, American Concrete Institute, this is the most important data, or the reference that you can take a look. So I have been doing the same exact steps for over 3 years. Let's continue. First layer.
Concrete around the mouth of the cone to evenly distribute. We'll rod this lip throughout its depth without forcibly striking the bottom. Half of my roddings are going to be at an angle to ensure that I get proper penetration into the corners. The rest will be across the cross section.
What is the reason he's rodding the first layer? He's trying to avoid something.
Bubbles?
Exactly. Perfect. Thank you, man. You deserve 10 points. Send me an email.
Okay.
25 times. I'm not gonna ask why 25 times because I don't know why 25 times.
Second lift. We'll fill the mold to 2/3 by volume. Rod this lift throughout its depth, penetrating the lift below by approximately 1 inch. Third and final lift will completely fill the mold. Rod this lift throughout its depth, penetrating the lift below by approximately 1 inch. If at any time the concrete falls below the lip of the mold, we'll add a representative portion of concrete back into the mold and begin rodding where you left off. With a rolling, screeding action, you'll strike off the top of the mold. The tamping rod is the only approved method for striking off the mold. Remove any excess concrete. We're gonna raise the mold in 5 ± 2 seconds, clearing the concrete slump by 12 inches. You don't want any torsion or side-to-side movement as you raise this mold.
Ooh, it's messed up. This is slump. This is a high slump. Probably about
Measure
9
down to
inch,
the offset center
8 inch.
and get your reading for your slump.
Too much water. This is slump.
Can you play that back again? Like I had a hiccup in like right at the most important part.
Froze for me for the last minute or two, or seconds or.
Yeah, we all seem to have gotten.
Like right before he lifted it. Yeah, there you go.
We'll invert the cone. Measure down to the offset center and get your reading for your slump.
I believe it's clear.
He's measuring a radius? What is he measuring? The diameter?
Okay. This guy, he knows. He's trying to measure how it failed. I mean, how much
How far the cone fell.
How exactly?
Okay.
So you know the initial height. Okay. You know the initial height. It is 12 inches, right? It's 12 inch. This is the initial height, right here. And after I remove this cone, come here, and I measure the difference, right? From the original height, original elevation, which was 12 inches, to where it is right now after I remove the cone. Make sense?
So what you're looking for is for that number that you measure from the top of the slump to, from the top of the concrete to the top of the cone, you're looking for that to be in the range that's like posted on the bag.
Exactly, 2 to 3 inches, exactly. If it is more than 2 to 3 inches, that means I added too much water, you know? And too much water means less strength.
It won't be as strong.
It's not gonna be strong. Definitely not. Okay, so with that being said, I answered the question on the slump test. Is there any other question about slump? No. Okay, so I close this. And you also have the handout for slump, right here. Right here. Definition of slump test. So the definition of slump. Slump is a measurement of concrete's workability or fluidity. workability or fluidity. It is an indirect measurement of concrete's consistency or stiffness. Right? You have these handouts. Don't worry. Just listen. You're good. And you can go into details, and it tells you the procedure. It's clean the internal surface of the mold and apply oil or water. Since oil is expensive, I go with water. So, place the mold on a smooth, horizontal, non-porous base, because I don't want to lose any water from the concrete, right? Fill the mold with prepared concrete mixed in 4 approximately equal layers. If you make 4 or 5 layers, it's more accurate. If you do 3, it's enough by ACI. Tamp each layer with 25 strokes of the rounded end of the tamping rod in a uniform manner over the cross-section of the mold. For the subsequent layers, the tamping should penetrate into underlying layer. I have my rod. I'm going to water this rod, and I'm going to start tamping. Remove the excess concrete and level the surface with trowel. I have my trowel here. If you don't know what trowel is, I have my scope. I have trowel, so I can smooth the surface with this.
In the video that you showed us, they said that you should use the tamping rod to level the surface. Is a trowel okay as well?
It's okay. I do use trowel to smooth the surface usually, concrete finishing, but this is also okay. As long as you have a smooth surface, you know, it's okay. Remove the excess concrete and then clean away the mortar or water leak out between the mold and the base plate. Raise the mold from the concrete immediately and slowly in vertical direction so you avoid any portion, you avoid any swing on the cone. And if you look at this figure, I believe it is clear explanation of what he did on the video, right? 1, 2, 3, 4, 5, 6. And when you come to your report, you can come here, you can look at the procedure that's already given to you. You know, just elaborate it or summarize whatever is convenient for you. So this is another handout that you need to reference. Note, the above operation, the operation should be carried out in a place free from vibrations. No vibration or shock within the period of 2 minutes after sampling. Because if there's any vibration, it will change the slump. Because it's going to start settling already. We use mechanical vibration to settle the concrete after we pour into the formwork because we want air free. We don't want any bubbles. We don't want any space in the concrete because if there is any space, let's say, if there is any space somewhere here in the cross section, my area was 28.3 inch square, right? If there is any gap and if the accumulation of, if you sum those gaps, and if it is, let's say 1 inch or 2 inch square, 28.3 minus 2 inch square is 26.3 square. Divide 1,000 pounds by 26.3 and look at the strength. Does that make sense? Okay. Okay. Okay, types of concrete slump. There are different types. You have collapse slump, shear slump, and true slump. He got the collapse slump, this ASTM guy. He messed it up. I don't know why, but it wasn't expected. Shear type of slump, it shears off 45 degrees almost, and then you have true slump. I expected to have true slump, but we will see. It explains the type of slumps, but I don't have time to get into this, but you can take a look at it after this course. Okay. And degree of workability, very low, low, medium, and you can take a look at this table as well. If you're looking for very low workability, this is the slump range that you want to be in, 0 to 1. It is very dry mixes used in road making, roads vibrated by power operated machines. And let's look at the extreme high workability, 4 to 7 inch high workability concrete for sections with congested reinforcement. And let's look at what is this congested reinforcement. Reinforcement is steel reinforcement. Okay, this is congested reinforcement. Oh my God. Imagine you have a concrete and you're trying to produce concrete over here. Oh, it's hard, boy. Imagine. As opposed to, or this one, look at this. Look at this. And I work in the airport construction in Istanbul. It was a huge airport. It's the biggest airport construction in the Europe. And I seen this type of reinforcement. Let's go where we were. Okay. So in this case, you need high workability. You need more slump so it can flow, the concrete can flow between the reinforcement, right? But you don't, at the same time, you don't want to lower your concrete compressive strength. You want to have strong component, right? This is when you need to use the admixture, okay? And we're gonna get into admixtures in a few seconds. Okay, so you got this part too. I assume that, oh, there are questions, and I'll also put the answer. So I don't want you to waste your time to answer them. Answer them. I have the answer. But look at these, because these might come up on the exam, midterm exam, okay? What is the ideal value of slump? You have the answer. How does a superplasticizer affect the slump of concrete? Superplasticizer is the type of chemical admixture that changes the workability of concrete. Value of slump can be increased by the addition of chemical admixtures like mid-range or high-range water reducing agents. Superplasticizer without changing the water cement ratio. If you add this superplasticizer, you can change the workability. You can increase the workability, changing the water cement ratio. How much time one should take to raise the cone? 5 to 10 seconds. Simple. So if you watch the video that I've been recording, and if you look at these handouts, you should be able to answer this question without hesitation. And since, assuming that we're gonna continue online classes, you're gonna have these open book, open notes, open Google, everything. So you shouldn't have a problem. Okay. Okay, what else? What else I have? I have the specs. You should take a look at the specs. Don't go into too much detail. Stick with the one that I show on the PowerPoint. But I just posted here for you to see if you want to take a look at it. You have concrete test handouts. This is the most essential handout that you need to take a look. On top of that, I highlight for you to pay attention what you need. It starts with the concrete definition. It's a mixture of sand, gravel, crush rock, and other aggregates. I mentioned here, I highlighted here what is important. Workability is important, durability is important, and time of hardening is important. And how to change it. Look, sometimes one or more admixtures are added to change certain characteristics of concrete, such as its workability. I can change it based on the requirements or whatever the desired value for workability. Durability, I can change the durability. And time of hardening. I think I forgot his name. Somebody was asking about the driveway. What if, he wanted to wait 28 days to open his driveway, but I can change the time of hardening. And there are materials, there are different type of Portland cements that you can use, like high early strength cement. It's expensive, it's more costly, but it enables us to obtain desired strength in 3 to 7 days rather than 28 normal days. And I can reduce from 3 days to overnight if I use different type of chemicals. You don't have to know everything over here, but just pay attention to what I highlighted. Look at those parts. And I wouldn't highlight it if it wasn't important. Don't worry about midterm or final. It is important when you get a job. Admixtures, right here. Materials added to concrete during or before mixing are referred to as admixtures. They are used to improve the performance of concrete in certain situations as well as to lower its cost. You have air entraining admixtures. It's used primarily to increase concrete resistance to freezing and thawing and provide better resistance to the deteriorating action of de-icing salt. Okay? And you have accelerating admixtures, such as calcium chloride. It is used to accelerate its early strength development. Retardant admixtures. They are used to slow the setting of concrete and to retard the temperature increases. And sugar or sugar derivative. I believe I mentioned that at the beginning. Sometimes, let's say you are a truck driver this time, you are delivering concrete to a job site in New York, Manhattan. Traffic is bad. So what you gonna do? And you have 90 minutes. You can throw sugar or sugar derivatives to retard the temperature increases and slow the setting of concrete, because I say the concrete starts setting at certain time, and it was 90 minutes. Last year, I don't know if it changed, but usually I did 2-3 years, it was 90 minutes. So check it out if you're interested. Okay, super plasticizers. That was a question that was asked in the previous handout. They are admixtures made from organic sulfonates. Their use enables engineers to reduce the water content in concrete substantially while at the same time increasing their slump. So I get high workability. So when I look at these congested reinforcement right here, I need high workability, but at the same time I need higher strength. I asked too much, but always the scientists, they came up with the admixture. So we as an engineers, we can use it. So if I use the super plasticizer, I get reduction on the water content, right? I'm not messing up with the strength, but I also increase the slump. So this concrete is working, is workable. I keep the water cement ratios constant while using less cement. They are commonly used to produce workable concretes with considerably higher strength while using the same amount of cement. What else you want? Okay. It tells you what the compressive strength is. I already explained. It is determined by testing to failure 28-day old 6-inch diameter by 12-inch concrete cylinders at a specified rate of loading. 1,000, 2,000, 3,000, 4,000, we go to failure. You know? For the 28-day period, the cylinders are usually kept underwater or in a room with a constant temperature and 100% humidity. I try to keep it 100% humidity, but it's not possible all the time. Okay. Although concretes are available with 28-day ultimate strengths from 2,500 psi up to as high as 10,000 psi, imagine, to 20,000 psi, most of the concretes used fall into 3,000, 7,000 psi range. Like you see in my concrete receipt, we use around 3,000 to 7,000 psi in regular construction purposes. But if you are working on the, let's say, airport construction or bridge construction, or skyscraper, tall, high-rise structures, then you need to go to 10,000 psi. If you want an example, you can look at the Abu Dhabi Tower in Dubai. I've been to Dubai and I look at those structures. They are huge, long, tall structures. When you think about the heat over there, it's also another problem in steel. I didn't mention the heat on this material. If you increase the heat, what's going to happen, Christian? If I increase the heat in the steel, it expands, right? Imagine the size of the steel frame that they use in Dubai. It expands exponentially because during the nighttime it's cold. During the daytime, it is hot. So you have shrinkage, you have expansion. So somehow you have to overcome this. They did it. Eventually it's working. But if you watch the video on YouTube, it's fun to see. And if you want to learn something about concrete, look at the Hoover Dam. Hoover Dam, one of the biggest concrete construction. And Hoover Dam is still curing. If you're not able to understand my speech, I will type it for you. Hoover Dam in Nevada. Hoover Dam, concrete. See, it's important, concrete is popping up. Approximately 160,000 cubic yards of concrete were placed in the dam per month. 160 cubic yards, as opposed to 10 cubic yards that I received from Lafarge, from the concrete seed, imagine. Peak placement were 10,462 cubic yards in one day, including some concrete placed in the intake towers power plant. That was a, I don't want to get into too much, but there was one instance that they tried to reduce the temperature because temperature is important. In this scale, it might explode. Imagine that this dam explodes. What they did was they used pipes, and from these pipes they were giving water into the concrete. But eventually, water is not getting into the concrete, but the pipes are cooling down the concrete. And at the end of the curing time, they fill the pipes with the concrete. They took the pipes and fill it to reduce the temperature. Imagine, it's important. And concrete, let's say temperature. See, it's coming up. It is still curing. It is Hoover Dam is still curing, by the way. Go ahead, Andrea.
Yeah, you had said that, and I was wondering how, what they assume when it's going to be done curing.
Well, I don't know, but all I know is it's been curing. Okay, the Hoover Dam concrete will cure in 125 years by conventional or natural methods. Okay. It is getting stronger every day, right? It's curing. Like I said at the beginning, this concrete sample that I have over here, I want to test it because it's been, I think, a year. So I want to see what happened. Is it 4,000 PSI? Because every year I test it, I use the same bag. And I want to see, what is it? I don't want to get into more details, but it's interesting, especially if you're a civil engineer. Please take a look at the Hoover Dam, how it was constructed and how they prevent the failures, etc. But they lost so many lives, that's all I know. Okay, so. Oh, this is also important. It should be further noticed that weaker grades of concrete are less brittle than stronger ones. That is, they will take larger strains before breaking. So let's say F prime C, which is the concrete compressive strength, 1 KSI here in KSI. This is the graph that you're supposed to have at the end of your report. It shows the curvature for 1 KSI, 2 KSI, 3, 4, 5, 6 KSI concrete. If you look at the first curvature, 1 KSI, before it fails, it goes, the formation strain value per unit length, the formation per unit length, it goes up to 0.004, as opposed to 6 KSI, look where it fails, 0.03. So if you have weaker material, weaker grade of concrete, it deforms more before breaking. Okay, just take a look at this handout as well on the highlighted portions. It will be beneficial for you. What else? We look at the first four, and then how to hand mix. Okay.
Mixing concrete.
Mixing concrete. Just 1 minute and 34-second video. You can watch it, but I will perform it right here in front of you. if you want to wait. If you don't want to wait, if you guys want to leave, you guys can leave. Whoever is going to stay, I can continue with them to perform the concrete, mixing the concrete batch, because I have to. But it's 5:38. How many hours we have? Let me see. It was 3 hours and 30 minutes, if I'm not mistaken. From 3:30 till 6:30. Okay, let me see the syllabus. Let me see the syllabus. 6:15 is only 5:40. So let's wait. So I'm trying to compensate from last week because I feel guilty. Okay? I want to
hand mixing.
Let's watch this
Quikrete
one.
concrete mixes can be successfully mixed by hand or machine mixed. For smaller projects, hand mixing is often the best method. When working with cement mixes, always wear rubber gloves and safety glasses during concrete mixing and placing procedures. Hand mixing can be done in a plastic mortar tub or wheelbarrow with a shovel or hoe. When hand mixing concrete, empty the mix into a mortar tub or wheelbarrow, and then form a depression in the middle of the mix. Measure the recommended water amount. Each 80-pound bag of concrete mix will require about 3 quarts of water.
3 quarts. I don't have the measurement, but I know these are 1 gallon. This is 1 gallon. That's what I know. So I go 3/4 of this 1 gallon. And I usually get 3-4-inch slump.
Pour approximately 2/3 of the water into the depression. Work the mix with a hoe, gradually adding water until the mix reaches a uniform, workable consistency. When mixing concrete, it is important to know the more water that is added to the mix, the weaker it becomes.
More water that you add into the concrete, the weaker it gets. Unless you use plasticizer.
An extra quart of water per 80-pound bag can reduce the strength of the concrete by up to 40%. Properly mixed concrete should look like thick oatmeal and should hold its shape when it is squeezed in a gloved hand. Adding liquid cement color to a standard grade concrete mix can turn it into a decorative concrete with professional results.
That's it. You can also add color if you are picky about the concrete color. You can change the color. Okay.
Will adding that liquid color weaken it as well, because that's a water mixture?
Well, I have never tried that. I believe so. I don't know. It's a good question. I can take a look at it, but not right now. But remind me if you want to know the answer. Easiest way to get answer, because this is what I will do. Adding color to concrete reduces strength. Let's see. This is what I will do usually. Okay. Problems can arise if excessive amounts of color added. The excessive amount of fine pigment particles demand more water, which increases the water cement ratio of the mix, decreases strength. I knew the answer, but I didn't want to give you the answer on top of my head because I don't want to cause any problem. Because you're going to be blaming on me in the future. Oh, my teacher back in the time, 3 years ago, he was saying that it's not a problem, but obviously it's a problem. So always ask Google. Google knows more than I do. Believe me. I still ask Google. Okay, so we got the answer for that. We watched these 3 videos and we went over the concrete report and we are ready for the concrete mixing. I'm gonna go with who I can ask. I'm gonna ask to Matt Garrett. Matt, can you give me direction, please, how to perform this concrete mixing? I can pull up, or you can pull up the edit. Okay, let's pull up this file. One second.
Just gonna go by the video, dump the concrete in and measure your water out, put that in, use a hoe, mix it up.
Let's see, I'm gonna pull up this handout, concrete receipt, SLAM test. Okay, this specs. Okay, everybody's looking at here, right? Okay, machine instructions. We don't have machine, but we have the hand mixing equipments. I have everything that I need, I believe. Let's look at here. Okay, empty concrete bags into suitable mixing container. And I have suitable wheelbarrow. Are you guys able to see? Let me see first. Let me see my camera. Okay, I have my wheelbarrow. And inside the wheelbarrow, I have my quick mix. It is 80 pounds. Heavy, really heavy. I don't have my gloves. I'm sorry.
And this is why PPE is really important.
This is why what?
Protection wear is
Oh,
really
exactly. This is I have my glasses. Basic glasses. But I forgot my gloves. So, the first step is completed. What is next? I believe
Measure the water.
with Garrett, but team, can you continue?
Yeah. Measure water out.
Measure 3 quarts of water.
Okay, measure 3 quarts of water. But I need to make a depression first. I need to make a place for the water. Well, next week, hopefully, I have my tripod here. I can put my camera. I can record it. It's hard for you guys to see what's going on inside, but I will measure my 3 quarts of water right now. Coming back. Okay, so I got my 3 quarts of water, but I'm not going to add all of them at the same time. I will just add the 3 quarts of 3 quarts water.
All right. I'll see you later, buddy.
Wait a second, I can't hear. Say it one more time, please. So if you want to take a break, you can take a break. If you want to go to the restroom or stuff, it's going to take a while for me to evenly mix it.
Bye, buddy.
The asking question I cannot hear right now. I can't hear. As you can hear, or as you can see, it's hard to work with this concrete at the moment because it doesn't have enough water. So it's asking for more water. Right? I'm going to add more water. I'm trying to get the oatmeal consistency. Like you guys say on the video. What about now?
That's better.
Better?
Yes.
I believe it's coming. Okay, now we're gonna check the workability. Salam test. Seems like, looks like oatmeal to me. Does it look like oatmeal? I believe so. So now it is time to prepare salam test. Prepare for salam test. I'm gonna move it a little bit. So salam test is gonna be taking place right here. Let me see if you can see the salam test. So I have this testing area. This is the only reason I'm using this because I don't want to mess up the floor. And I'll be in trouble if it deep. So I'm gonna put some water, a little bit. But I'm gonna put water right here on this thing, right? This is the pop, one of the tools that we use in the salam test. It just gives us the smooth surface. And when I put water, I have water here. You can use oil, olive oil, any type of oil if you have. If you want to go with oil, but water is enough. Okay. What about my here? This is the salam cone that I was showing. I'm going to wash it, water it around and inside and out, coming back. Okay, now I washed it. Everything is clean. Not perfectly clean, but you can achieve or optimize it. Cleanness. It's up to you. Get all the impurities up. Okay, so I can lock this in place So it doesn't go anywhere, it doesn't move, there's no shaking, there's no movement, there's no vibration, etc. Right? It's inside. I need my shovel. I need this scoop. Again, this needs to be washed or watered as well. All right, let's start with the first layer. Okay. If you want to follow the procedure, you can look at this handout, slump test handout. You can tell me the process step by step. Who is going to go first? Can somebody pull up that handout and tell me the first step? How am I going to fill this slump cone?
You gotta fill it 2 5/8 of an inch.
Okay, more specific, but I'm going to make 3 layers, okay? Let's make it 3 layers, and I'm going to go with the first layer first. The first. I got the first layer. Here's my clamping rod. I have my sampling rod right here, and I have my measuring tool. How many strokes? 25? Right? 25?
25.
Yeah.
Thank you. And if you go above 25, you're gonna start repeat one more time. Do you know why? I said if you go, what is it?
I did not
It's
hear
kinda
what
hard to
you
hear you.
asked.
Yeah.
I can't hear you.
We can't
That's
hear
the
you.
thing. We couldn't hear what you
It's hard
said.
for
What I was saying is if you go over 25, you have to start again. If you do 26, you gotta start from the beginning.
No, you don't.
No, you don't. You don't. You don't. Okay, the first 25 is done. First layer is completed. I'm gonna go to second layer. Okay. Second layer is done. Okay. 1, 2, 3. 25. 25. Third layer.
I have a question for you.
I got
When you're doing the 25, you're not going all the way to the bottom. You're just going into the layer you just did, right?
Right. I can only penetrate up to 1 inch in the previous layer.
Okay, thanks.
Okay. When you start the first layer, not good. Because it counts 26, 27, 28 on the different low layers. I already did 25 times, and if I go down again, it might create another bubble. I might cause problems. Okay. I need more. A little bit more. Okay. As long as I have a smooth surface at the top, I'm okay. So, I usually have my students to help me in this phase. But since I don't have my students, I'm going to be so quick to measure the slope. So I'm going to remove it 90 degree vertical, really quick, and then I will measure it, the measure. Okay, so. Unos, dos, tres. Perfect. So, has to be right here. Has to be right here. And this has to be right here. Now I can measure. Guess what? Guess what? It is 3.5.
3 inches? Okay.
Okay? Let me wash my hands and I'm gonna come back. Actually, before I wash my hands, I have to fill these. Okay. These cylinders, I have 2 of them. Again, I have to wash these before I put the concrete in, because if I don't wash it, it's gonna absorb the water from concrete, right? I have to water it. Okay, these are nice and clean. I have to follow the same procedure. I have to do 25 times each layer. 3 layers on this one, 3 layers on this one. Are you guys able to hear me?
Yes, sir.
Yes.
Okay. My first thing. 1, 2, 3. Second layer. Also, to give you guys a side note, this is not your job because you're an engineer. You always have your assistant or you always have your lab technician to do this job. My wife is gonna be pissed after she sees my face. Thirdly, and I always have my students to help me. So they get the job done. And I just tell them the direction. But this here, they are telling me what to do, and I have to do it by myself. More than 25. You should always shoot for smooth surface. And I explained why we need smooth surface before. Why we need to add sulfur cap or another cap. And it is to distribute the applied load uniformly. It is smooth enough right now. I'm gonna go for the second one. First layer. Second layer. And last one. What I will do is I will make one more because I have leftover concrete mixture. This one is extra. I will make that as a spare specimen. So if something happens to one of them, I can use the other one. But I'm not gonna waste my time right now. I will finish this class and I will make the third one for you guys to be in the safe side, so I can have another specimen if something goes wrong with any of them. I don't want to waste the concrete. Even though it's cheap, you don't want to waste anything. Okay. If you want to take a look at it, by the way, this is the real barrel that I use. And I have my 2-cylinder. Look how smooth it is. They are pretty smooth. And this is the concrete bag that I use. 80 pounds, just add water. And if you want to look for product number, right there, product number 1101. Okay. Let's continue.
How do you get the samples out of the casts once they're done curing?
Okay. You gotta be rough. You gotta get your hammer, or you gotta cut it somehow. Plastic is waste, you know, you're gonna waste it. So you cannot take out the plastic without breaking the plastic. Somehow you have to break the plastic. So every year we have to buy new plastic. I don't like to hurt the environment, but I have to sometimes.
Oh, so you cut the casts, you cut them off?
Yes, sir. Okay. So we mixed our samples. Everything is good to go. Let me share my screen. And I'm recording the video. Perfect. Share the screen. Share the screen. Share it. Perfect. So I believe at this moment, nobody has question in this class. I don't know how many of you, how many students I have, but if I get any bad report on tensile experiment, I'm gonna assume that they didn't watch anything, they didn't follow the procedure, they just want to pass this class with a C or fail it. But if you follow this procedure, there's no way that you can get less than A. You know, and I'm easy when it comes to grading. But I can be easy if you are messing up, if you are mixing apples and oranges. Like, there is no such a word. Like, you cannot. Because whatever I do, somebody is watching me. Because everything is posted on Moodle. So there is, not here, but I can show you guys on the Tuesday section, the way that you have to submit your report. It should be this way. Let me see. Okay. 496 is Tuesday. Okay. Tensile report submission. Wednesday, September 16. I give them one more extra day, yes, but anyway. So you should submit all your report through Moodle. If you send me an email with an attachment that has Word file and spreadsheet, 2, 3 different files, no, I can't accept it. Because what I have to do, if you send me an email, I have to download the attachments, right? And then I have to go to submissions. I have to find you, each individual student, if I'm assuming they're submitting the reports via email, and I have to download it and submit it on behalf of you. It takes me about 5 minutes to download it and find you on Moodle and then submit it on behalf of you. Imagine how long it will take for 20 or 30 students. So there's only one way to submit, and there's a restriction. You can only submit PDF files, and it's not going to accept it. It's not going to accept the any other file rather than PDF. And I mentioned how you can make PDF file from Word. It is simple, super simple. And if you don't know, you can ask me again over the phone. I can explain you how to convert to PDF. Tensile is done. I don't want to hear anything about Tensile. I don't want to talk about Tensile.
Real quick about Tensile. I actually have it pulled up right now. I can't see that submission file right there.
Yes, you don't have it. That's why I'm looking at the Tuesday section. This is on Tuesday. On Wednesday, I have not created yet, but it is not too hard for me to create it. I can just come here, add an activity, go down, assignments, add, simple.
Thank you.
No problem. I'm not gonna put due date. Okay, let's put September 16. Okay, I'm gonna give you one more date. What is September 16? Is it Wednesday? Oh, it's Wednesday. Okay, September 16 will be now. So 9 and right here. Accepted file types. PDF. Right here, document files, and I'm gonna collapse. I'm not gonna collapse it, but I will find the PDF. So now I prevent for you to submit any other document than PDF. So even if you try Word file, it's not gonna, you're not gonna be able to upload it. And save and return the course.
It looks like you have it set so you can submit both document files and PDFs. It looks like you could submit a Word document.
It looks like? I don't think so. Because what I did was you cannot try PDF only. But why would you try? Just do the PDF, you know? Just go onto your, like let's say you have the Word file. Okay, I'm gonna pull up something, tensile test. Okay, so I come here, Control P. Can you see the printer option? Okay, I can select different printers, but also I can select Microsoft Print to PDF. Once I do this, it's gonna ask me where to save it. And I can go to my desktop, for example, and I can say tensile test report PDF final version. If you have the different version, just save it. Okay, and then I'm gonna go to my desktop, Tensile test report final. I have the final. Right? Super simple. Once you have everything on, okay, first thing first, you're gonna write your theory sections, objective, discussion, and procedure on the Word. Only thing is gonna come from Excel is your data and results. Once you copy and paste the data and result to your Word file, you can print it as a PDF. You can save it on your laptop, and then you can submit it to Moodle. Is that clear, Mark?
Yeah, it's clear.
Thank you, sir. Thank you. Okay. So, one more slide. Okay. Objective was clear. You can see that I said okay to the students whoever submit this report. Equipment use is missing one equipment, which is a wheelbarrow. He forgot to add wheelbarrow. But I believe he assumed that slump test equipment is consisting this wheelbarrow. And I said, refer to the files on the Moodle. For example, concrete test handout or videos. So for theory section, you should refer to these files so you can write your theory. Procedure. Pour bags of cement into large container or barrel. Select proper amount of water cement ratio in order to achieve appropriate strength. You can, I didn't do this, but he tried to show off, I guess. He just added his wording. Mix quickly until water is fully absorbed. Pretty much the same things that we discussed. He just write on the procedure. So I want you to write the procedure in a way that I understand that you look at these files and you look at the experiment and you understood and you're able to summarize step by step how to complete this procedure. Okay, test. Once the first cylinder reaches 7 days, complete a compression test to determine maximum compressive strength. After 28 days, complete a compression test for second cylinder. After 28 days, we're gonna test one more time. And then we will tabulate and graphically analyze the results. Right? What do you understand when you look at this table? What do you understand when you look at this graph? By the time we finish these two lectures, first one today and the second one next week, you should be able to read and analyze the graphs. If not, give me a call. I will help you to analyze it. Okay. I even put these videos here. So either you watch the videos on the Moodle links or watch it from the PowerPoint. Okay, that being said, it's good to go. I believe, give me 1 second, I had one more file. Show me.
So we don't have any of this due next week, right? We're just like introducing us to it and we can start a report, but we don't have to do the concrete report or anything for it by next week?
There is only one report due next week, which is, you tell me what is it?
Test.
Thank you so much. Thank you so much. That was the right answer. Okay, let me pull up this file. Okay. Okay, concrete experiment. I have the videos, sample concrete reports, design, concrete test handout, concrete receipt. Okay, this one. So, this is what I will give it to you. I will give you this one. Similar table, similar structure. Like I work in a way that everything is easy for you to put the numbers and then calculate the required sections. So what did I say at the beginning? You gotta measure. We already measured the diameter, calculate the area, cross-section area 28.3 inch square, length 12 inch, and all you need to do, write the slump. What is slump? 3.5, right? Put the slump here. And then I will give you the data after I run the test. I will give you the change in length corresponding to applied load, right? Based on this data, raw data, you should tell me what the stress is, corresponding stress. And you should calculate the strain for 28 days and 7 days. Okay, there is one thing is unknown right here. And this is the #1 question they ask when they are doing the report, because there's unknown values, so you don't know what the strain is at this point because you don't know the elongation. I don't give it to you. Okay. It says note, change in length delta L at failure. So whenever this concrete crashes, I don't know what the length is. I can't measure it. You know, it's already failed. Was not measured for 7 days and 28 days strength test. According to the testing procedure, compressometer must be removed before failure of the concrete cylinders to prevent any damage to the compressometer because they're expensive. This is extensometer because it's extending, elongating. This is for steel sample or aluminum sample for tensile. And I have another one for compression. That's why it's called compressometer. Okay, so this goes here after I take the plastic, right? So I try it, put in place. Anyway, once it's in place, this little thing right here, this gauge, it's gonna tell me what is the deformation is. But I cannot keep this on the specimen all the way to the failure, because once the concrete fails, extensometer is going to fail as well. So why would I waste $500 just for one cylinder? So I take it off. But I show you the way to calculate. Okay, let's continue. Strain value at the failure point can be determined from the graph by drawing a vertical line from F prime C, which is the concrete compressive strength, to the strain axis. See figure 1. Okay. There's a straight line, F prime C at 28 days, concrete compressive strength. It is a little bit above 4,000 PSI, between 4,000 and 4,500, 4,500. So if I draw a straight line to this trend line, to this curvature, I can predict what the strain is at the end of 7 days, right? But all I'm looking for is the F prime C, concrete compressive strength. That's all I need. As an engineer, that's what I look at for contractors. Let's look at this. I want 4,000 PSI concrete. If it's 4,000, it's good. If it's not, no good. This way. But for the purpose of this report, if you're going after your PhD or your master's in structural analysis or concrete, you need to know the details. But you don't need to know right now. But if you follow my procedure, everything will be clear in your head because I gave you the answer right now. Okay? It's going to be hard for you to do the trend line options because you can only get the graph up to this point because you cannot graph it, tabulate it. You cannot graph it if you don't have one data. One is missing because you have the data for y-axis. It is 4,200 something PSI, but you don't know what the value is here. So you cannot plot it, but you can manually plot it. We're going to get there, so don't freak out.
Okay, I need to go. I have another meeting at 6:30 and it's 6:22.
Okay,
will you continue the recording?
Yes, it's recorded.
Okay, thank you. Have a good night.
Have a good night. Okay, I'm almost done, 5 minutes. And you have to answer this following question on your report. Compare using percent difference the design compressive strength 4,000 PSI with the actual result. 4,000 PSI was advertised in this concrete mixed bag. So I'm shooting for 4,000. You just need to compare. Why it is 4,200 instead of 4,000 PSI? Obviously, something went well, or I reduced the workability by adding less water and I increased the strength, or I cure more than it was supposed to, or some good thing happened. Will your concrete mix work for the design that requires minimum 4,000 PSI concrete with 3-inch slump? You answer. The effect of water in the mixture before and after setting. How water affects, and somebody asked me this question. I believe it was Matt or Brad or Mark. Somebody asked me what is the water, how this is affect. So if you go back to the first portion of the video, the answer is there. or on the handouts. What are the factors that influence the magnitude of F prime C? In other words, what factors that changes or contributes to concrete compressive strength? Temperature, water, cement ratio, humidity, etc., etc. So you name it. You can just also ask this question right here. It's not called cheating. It is just knowing the correct answer. But if you do this, if you just come here and if you copy and paste it by just not even looking at it, if you just control, copy and paste it, if you don't even read it, sometimes there are stupid answers, right? Because I received it a couple of times. Somebody was giving me answer in computer science. He didn't even look at the report. He just copy and paste. So I can't accept this. So make sure you are at least copying a word that is related with civil engineering or engineering field, not mechanical. Because there are technical terms that we use and they have it in computer science or in a different science. So make sure you're copying it correctly. Like what I'm trying to say, understand, try to understand. You know, you spending thousands of dollars on your education, at least try to get the most out of it, okay? It's beneficial for you. Good. I think we are done for today. This is my longest class that I ever had because I just wanted to make things straight. You know, now we are on the same page. I understand sometimes you guys are gonna get sick or overload with the other school stuff, and my wife is about to go to labor, so I might miss class. But if I ever miss class, I will make sure that I will record this video and I will make sure that video is on YouTube. And if you like my video, please press that like button on YouTube and subscribe my channel, okay? Agreed?
Yeah.
Yeah.
Okay. Okay. Thank you for everything, for staying with me 3 hours. I will see you guys. I want to get a picture before I leave. Wait a second. Wait a second. How can I? Why I cannot see everybody? Okay, now. 50 students. I don't know when I will get 50 students again in my life. 50. Okay. I have less than 50. Now I can see that. Some people are missing. But this is going to be the proof of who's staying, who's not staying. Let me see.
Helen Fajimi, her internet went out, and so she has to watch the lecture later.
Okay, that's okay. I was just teasing. Okay, all right. Thank you guys again. I will see you guys next week. Feel free to call me if you have questions. Thank you.
See you next week.
See you next week.
Thank you.
Can I ask you a question now that we're done? I don't want to hold anybody up.
Yes, go ahead.
I had two questions about concrete. First of all, since it doesn't dry, it cures through a chemical process. Does it cure uniformly? So it would be like, is there a situation where it would be less cured maybe on the inside than it is on the outside, or vice versa?
Yes. Yes.
Cool.
It's a common problem. It's a common problem, and there are ways to avoid it. But I can't think off the top of my head. But if you write that question, if you type it, and if you send it to me, I'll get back with the answer as soon as possible. It's a common problem. Because imagine this is your cylinder, right? And you can see through, right? Some parts might not be getting water. The way to avoid this, the reason that I spend more time on the mixing, right? It has to mix thoroughly, right? As long as it's mixed thoroughly, all the water particles, they are going to chemical reaction with the cement, right? Uniformly. So mixing is one of the criteria, but I'm sure there are other ways to, like, we use mechanical vibrations in some construction sites. If we have congested reinforcement in the case, so if you vibrate it, this one, for example, if you vibrate, avoids the air bubbles inside the concrete form, but I don't know if it affects the I'm not quite sure, but I don't want to give you the wrong answer.
Yeah,
but
that's cool.
The mixing is one way to avoid this.
But so it does frequently like cure non-uniformly, is what you're saying.
Yes, I mean, I never experienced it before.
Sure.
But usually we take the concrete formwork in 3 days, 3-4 days. We take the formwork, and then you go to second floor and the third floor. Let's say you work on the 5-story construction. You finish the first floor. You take the concrete formwork until you keep it until the concrete cures, and then as soon as it cures to the desired strength, like as soon as it gains the desired strength, like 4,000 psi, you take it out and then you go to second floor.
All right, cool. Well, I had a second question, but I forgot what it was, so I'll save it for next time if I remember it.
Okay. Thank you.
Yeah, thanks.
No problem. Who else? Any question, Kate? If you don't have a question, you're good to go. Do you have a question, Kate?
Yeah, I do. Can you hear me?
Yes, is it personal?
All right, so no, the modulus of elasticity is it can only be applied when stress is less than yield strength, right?
Yes, sir.
Okay, so that's going to be the point that is our elastic region for both the concrete and the tensile test?
For tensile, it's when it's less than F prime C, but for concrete, it is when it is less than F prime C, half of the F prime C. Okay, half of the F prime C. 1 second. It was on the handout, and I'm positive it's less than 5 prime C. Right here. Okay. Right here. In steel, you can calculate it when the modulus of elasticity is less than yield strength, sigma 1. In this one, we don't have defined yield strength. We use the F prime C, half of the F prime C, as a point to determine the modulus of elasticity. That's why when you come down, okay, F prime C divided by 2 for 28 days. So this is the point, or this point, and you calculate the modulus of elasticity in this range. You see that slope, they're calculating the slope right here?
Yeah.
Okay. Same way for 7 days. You see over here, F prime C compressive strength at 7 days divided by 2. It's right here. So we define it here. This is the point, and I can only calculate in this region.
Okay.
The elastic region. Okay.
Okay, that clears it up. Thank you.
No problem. No problem. And there's also one more way to calculate it. This is more accurate. This is what we use. This is what I use, actually. And if you take concrete class, this is what they're gonna show you. Modulus of elasticity calculated by using the American Concrete Institute equation, 57,000 multiplied by the square root of F prime C. This will give you the answer. And it's not gonna be different than, it will be slightly different than what you get over here. You know, but if you, in your case, you should do it both ways in your report. You know, if you calculate it both ways, you're gonna get more points. And that's why I gave you this equation as well. You can check your work, and you should calculate both ways, so you understand both ways of calculating the modulus of elasticity.
Yes, sir. Thank you.
No problem. Have a good day. What about Claudio Aguirre? Do you have a question? George Selden? Okay, I believe there is no answer. Stop share.